All right, so we're going to start 5-3 with some notes. Normally when I teach it in the classroom, we write these on the board so we kind of get a better idea of what's going on. So I'm going to talk them through. So the first note is the fundamental theorem of algebra, and I will email these notes out and put them on Blackboard. And it says that every complex polynomial function of degree n greater than or equal to 1 has at least one complex zero. So the big deal here is every complex polynomial function. So complex again means that it has an imaginary number piece to it. Okay, so it's going to have one complex zero. So we're going to have an I as part of the zero. So coming from that comes the conjugate pairs theorem. So we have a polynomial function whose coefficients are real numbers. So similar to what we were doing in 5-2, it says that if we have a root that's a zero of f, a plus bi, the complex conjugate, the other pair, is the opposite of the middle sign. So you're going to change the imaginary part. If it's plus, it becomes minus. If it's minus, it becomes plus. Okay, so if there's one imaginary number, there has to be the other, no matter what. And then coming from that theorem, if you ever did geometry proofs, it's kind of like a corollary, something along those lines. This one says a polynomial function of odd degree with real coefficients has at least one real zero then. Okay, so you can only have pairs of imaginaries. So if you have an odd number, then you have to have one real zero along the way. So we're going to use that to do, we actually only have 3 problems, but they're a little bit in depth here. So we're going to go to the whiteboard. There we go. Number 7. We're going to find the remaining zeros of f. So of our function. Okay. They're going to give us the degree. So our degree on this one is 3. And then they're going to give us the zeros. Okay, our zeros are 3 and 4 minus I. Okay, so we have a real zero. So this one's a real. And this one's imaginary. So I'm going to take the conjugate pairs theorem and use it to create one that goes with this one right here. So all I have to do is change the sign in the middle. So 4 is going to stay positive, but I'm going to change the middle sign to 4 plus I. So this is my answer. This isn't meant to be super hard. It's almost a gimme problem. All right. The next problem is one that takes a while, and some students just go and kind of just don't want to do this problem, and it's up to you, but we're going to go through it. It is problems that are going to be in your problem set. So I'm going to try and write smaller because it's hard to fit. So I'm going to form a polynomial function f of x with real coefficients having the given degree and zeros. So it's going to look a little bit at the beginning. Oops, switch to red. Zeros. And then to green. This is how this is going to go, I guess, on this lesson. All right. So the degree is 4. And the zeros are 3 plus 2i and 4 multiplicity 2. This is the hardest problem you'll see on the problem set. All right, so I'm going to start it off on this page and try and write it out. And then I'll probably flip to the next page when I start multiplying it. So this is saying we're going to take f of x, and I'm going to start with the real piece first. Okay, so the real piece is this 4 multiplicity 2. So I'm going to write x minus 4, so remember it's opposite, squared. So that multiplicity 2 makes that there. Then I need to write x minus, again, the zeros are always minus. The first one is 3 plus 2i. And the second one is going to be x minus the opposite, so 3 minus 2i. Okay, so what I'm going to do here is I'm going to change the signs in the last 2 parentheses. So I'm going to simplify these before I do any multiplication. So I'm going to get x what I'm going to do on the next page is I'm going to do x minus 4 squared. That's my perfect squared binomial. We talked about this a lot early on. Remember, it's x squared plus 2xb plus b squared. So I'm going to do that, and then I'm going to multiply out the other piece. So I may go back and forth on the whiteboards here, especially because I know how to do it now. All right, so the first binomial is going to be x squared. Oh, press the eraser, sorry. X squared. So times 2, I'm going to do 2 times 4, and I had a negative, so it's a minus 8x. And then squaring the 4 plus 16. So that's my first parentheses. Then if I go back to the other whiteboard here, I'm going to take x and multiply it by the whole last parentheses. So I have to distribute it. So I'm going to get x squared minus 3x plus 2ix. That's the first piece. Then I need to take negative 3 and multiply it by the whole parentheses. And I get minus 3x. Oops. Minus 3x. Minus 2ix. Oops, 2ix. Let me double check here. I think I did something really strange on my paper. Let me go back to the screen and make sure I'm multiplying right. So I have x squared minus 3x plus 2ix. Okay. Minus 3x. I'm missing the plus 9. And then I need a minus 6x. So I don't know what happened in my multiplication. Let me do this again. So I need, again, a plus 9 and a minus 6i. So let's get rid of that. It's really easy to make mistakes on these. Plus 9 minus 6. Two ix plus 6i negative 2, oops, negative 2ix plus 6i, and then the last piece is minus 4i squared. All right. So what I need to do next is simplify the back parentheses. The front one's already fine for now. So what I need to do here is combine like terms. Some of the things that always happen on this problem in the back parentheses are the two ix's always cancel. The next thing that happens is your i's always cancel. So these single i's will always cancel. And then the last thing we are going to do is your I squared. Remember, I squared turns into negative 1. All right, so now we're going to simplify. So I'm going to copy my first parentheses, x squared minus 8x plus 16. And I'm going to go left to right. X squared, that one's good. I cross that one off. And then I have a negative 3x, and a negative 3x gives me negative 6x. The 2ix and the 6i's, those cancel. All right, and I have a 9, and I have a plus 4 now. So 9 plus 4 is plus 13. I don't know what just happened. Let us hit undo. There it is. Great. Plus 13. Okay. Now I need to do kind of what I did before. I'm going to take x squared and multiply it by the back parentheses. All right. So I'm going to get x to the 4th minus 6x cubed plus 13x squared. Ugh. Let me erase that one. Not very good. There we go. Then I'm going to take negative 8x and multiply it by the back. So I get negative 8x cubed minus, plus, sorry, 48x. 48x squared. And then minus 104x. Then last piece. I'm going to take plus 16 times the whole back piece as well. So I get plus 16x squared minus 96x plus 208. All right, last row, I'm going to combine like terms for this last piece. So here's my x cubed. Here's my x squareds. Here's my x's. So those are all my like terms that I need to combine. So I get x to the 4th minus 14x cubed plus 77x squared minus 200x plus 208 for a equals 1. Imagine what would happen if your coefficient in the front was something other than 1. That thing is gigantic. So you can get very large numbers, especially here at the end here, where you see you got a 208. You can get big numbers here and here. You can get some really big numbers on a few of the problems. Sometimes the numbers are really nice. So just be careful, really be careful among all of the terms. It's really easy to make mistakes along the way. Don't get overly frustrated. If you get stuck on one of these problems and want me to look at your work, email it to me. I'd be happy to look at your work and find where you made your mistake. All right, we have one more problem. Okay, so this one's similar to the last section. Oops, I don't want blue right now. Let's do black. 33. So we're gonna find the complex zeros of each, there's only one, polynomial function. Write f in factored form. This was a problem on the classwork. So I'll show you what that exactly means if you're having trouble. All right, so we have f of x equals x cubed minus 8x squared plus 25x minus 26. Okay, so in the last section, we talked about a couple different things that are going to help us out here. One, we have a cubic function, so we have degree 3. All right, number 2, it says that it's complex. So we're going to have a complex zeros here. So 2 complex zeros. We're going to have 1 real 0. Okay. Then we could look at what the possible rational zeros are. If I can write, that one's not very good. There we go. By doing P over Q. Okay, so the multiples of 26, plus minus 1, plus minus 2, plus minus 13, and plus minus 26. So if when I look at my graph, I have a number, so we're going to look at the calculator. I'm not going to do it here, but we've done enough practice at this point. Okay, and you see that you have a 0 at 2. If your 0 is not within the regular window, now you know to expand because it could be at 13 or 26. Okay, so we know that x minus 2 is a factor. All right, so we're going to put 2 in the box. And we're going to put the coefficients across. We're going to do synthetic. 1, negative 8. 25, negative 26. 1 comes down. 1 times 2 is 2. Negative 8 plus 2 is negative 6. Negative 6 times 2 is negative 12. 13 comes down, and we get 26, and we get 0, which is exactly what we wanted again. Remember? Check. That's great. That's what we want. Okay, so right now we have the function f of x equals x minus 2. And the other one is x squared minus 6x plus 13. Well, we need to factor this x squared minus 6x plus 13, but it doesn't factor nicely. And there weren't any other zeros on our graph because they're imaginary. So we're going to have to factor it either completing the square or quadratic formula. So let's do completing the square. So x squared, let's not do green, x squared, oops, minus 6x plus 13 equals 0. Remember, I'm going to move the 13 over. So I get negative 13. I'm going to divide by 2 to get x minus 3 squared. I'm going to square that to make 9. So I get 9 here and 9 here. I get negative 4. Take the square root. X minus 3 equals plus minus 2i. Remember, we need 2 of them. X equals positive 3 plus minus 2i. All right. So again, remember the instructions said find the complex zeros. Okay, so that'll be one blank, write f in factored form. Okay, so complex zeros, this is strange, I wouldn't have thought this, but this is what happens on my math lab. They do want you to include 2, even though 2 isn't a complex zero, but do put both of them in. All right, factored form. They'll have likely put in f of x for you equals, and then you're typing it in. So the first piece is x minus 2. We have a 3 plus 2i. Just like in the last problem, we're going to put 3 plus 2i behind a negative sign. And then we're going to put x minus 3 minus 2i. And then you do have to distribute. So x minus 2, x minus 3 minus 2i, and x minus 3 plus 2i. Some students go straight to the answer, write this one as their answer, and don't show the work of the line before, and that's okay. So if you've done enough problems after doing the notes, doing the classwork, and doing the homework, and then you're like, hey, I got this, I don't need to write out this line right here, no big deal. Just make sure that you write it out in factored form. That's a big deal. That'll lose you some points on a test or a final exam. Okay? So that should be it. There's really only 3 major problems. And I'll let you know